In this video, we're going to be looking at an example of predicting the precipitation reaction within a double displacement reaction. And we, once again, are going to be using our solubility table. So we're asked here, what substance will precipitate if a solution of copper sulfate is mixed with a solution of magnesium nitrate? So our first step is always going to be to write out the balanced equation, which I've already done since we've had practice with predicting products and balancing in a previous unit. Notice here as well I put the subscript AQ for both of the reactants because we're told that each of them is a solution. In our course, that means dissolved in water. I can't put a subscript for the products yet because we don't know if either of these are going to form a precipitate. We'll have to see. So after we have our complete and accurate balanced equation, our next step is to look at the products and then from that determine what the two ionic equations would be for this reaction, since double displacement is kind of like two reactions happening at the same time. So we have magnesium sulfate. So the two ions that are going to have to combine to form that compound, we know that that would be magnesium 2 plus. And again, the magnesium 2 plus, that charge, we know that from the common ionic states. And we're going to have to also have the sulfate anion. And in that ionic equation, those two ions, they join together and they're going to form magnesium sulfate. So the reason why it's like this is that you can also think of double displacement reactions as kind of like ion exchange reactions. Alright, we have the first one. Now we need the copper nitrate. So the ions that would form copper nitrate, we would have to have a copper cation as well as the nitrate anion. And again, both of these charges we know from the first unit where we looked at the common ionic states of different elements as well as polyatomic ions. That's where we get those charges from. And then we know that these ions would combine together to form the copper nitrate compound. Alright, so our next step is going to be to go back into the solubility table and look to see if there are any intersections where the ions would form something insoluble. Right, because insoluble means does not dissolve in water, so it would be a product. It would be a solid product. So we'll look at magnesium and sulfate first. So just like we've seen before, our first step there, we'll find the magnesium cation at the top, and then let's look for the sulfate, so the SO4 2 minus. Okay, there we go. And then we'll look for the point where they intersect in the table. So we move down the column across the row, and there we go. So magnesium sulfate is soluble. So in that case, that means it dissolves in water. So I'm going to put the AQ subscript so that we can keep track of that and we know that it's aqueous. Right, now we're going to look at copper and nitrate. So we'll find the copper. So copper is right here. And then we want to find the nitrate. So nitrate. So there's NO3. And we look for their point of intersection. So we move across and we move down. And there we are. So this is a white square. So that also is soluble. Alright, there we go. So Neither of these ionic equations, like neither of these components of the double displacement reaction, are going to form a precipitate. Both magnesium sulfate and copper nitrate are soluble in water, so no precipitate or solid forms. So we'll just say, therefore, no precipitate is formed in this reaction. And this is something that can happen. It's very possible. You are very likely to be able to mix two solutions together and no solid forms, right? That happens a lot. We've seen that in previous units as well. Something to keep in mind, though, is that if no precipitate forms, sometimes that just means that there's no evidence of a chemical change. So while we can assume, right, we can assume that this is a double displacement reaction, theoretically speaking, we may not be able to actually know that. All we can know for sure, and what we've been asked for, is just, did a precipitate form? And no, it didn't. So to recap what we were doing, we started off with predicting the products of the double displacement reaction and balancing the reaction equation. Then we looked to the products to break them down into their component ions to create the two ionic equations. So what are the kind of ionic exchange reactions here? Then based on the products that were formed, we looked to find the point of intersection of their two ions on the solubility table to see if they would form a soluble or an insoluble product. And then since both of the products were soluble, no precipitate forms.